Okay, so in the second part, we will talk about electric current and later on electric power. So let's first talk about electric current. So when we say current, it's simply the movement of charge, okay, or the flow of charge, if you want to say that. But if you want to be more specific, current is the flow of charges over a cross-sectional area of the wire over time. So for example, if you get a cross-section of this wire, okay, so this is the resulting cross-section. Ilang charges? The number of charges. How many charges are flowing through that cross-section? And then divide that by time, you will get the current on the circuit. Okay? So you can get you can take it from any point of the circuit kasi charge is the same everywhere along the circuit. Okay? And then how does it flow? How does it flow across the circuit? So tulad ng pinapakita natin before, so the current will flow from the positive terminal and then to the light bulb and then to the negative terminal. So we are assuming the flow of a positive charge, diba? You might be asking, diba sir, it's the electron that are actually mobile, that are actually moving. So diba dapat the movement is from the negative terminal kasi yun yung high potential point niya towards the positive terminal, diba? That should be the electron flow. And yes, you are correct. But what we are following is the conventional current or the convention. This is based on tradition. Kasi before, it was Benjamin Franklin, diba, who first studied this very, very deeply. And he was the first to assume that it's the positive charges na gumagalaw or nagpo-flow in a circuit. So, yung convention na yon got stuck and yun yung ginagamit natin until today. But yes, you are correct that it is the electrons that are actually moving. But anyways, we will follow the conventional current direction. Okay? By the way, since we have this formula, current will be coulomb per second. And then the unit for current is ampere. Okay? So current over seconds. That means that if there are more charges flowing through the cross section, the larger will be the current, the I. The symbol for current is I. Okay? And then if that happens over a shorter period of time, the larger as well is the I, or the current. You can abbreviate ampere as A or amps. That means that 1 ampere means that there's 1 coulomb of charge flowing through the cross section every 1 second. Remember how there are many charges in 1 coulomb. So this is how it flows through or around the circuit from positive, that's the convention that we will follow, from the positive terminal towards the negative terminal, as if it is the positive charges that are moving. How actually are the electrons or the charges moving as an individual? So kita mo dito, bakit zigzag yung, hindi ba diretso lang? Bakit zigzag yung yung motion ng electron along the wire? Kasi actually pala, when the electron moves this way, for example, it's actually bumping, nagko-collide siya dun sa mga atoms ng wire. So pag nagko-collide siya, kaya siya nagkakaroon ng back and forth motion. It is said from the source that for every one parang 3-step forward, there's a 2-step backward na nangyayari dahil sa collision between the charges and the atoms of the wire. That's why actually this process is very slow. The movement of the charge, of the individual charge, is very, very slow. Okay, because of this collisions. The movement of the charge is called drift speed. Drift speed is very, very slow. Okay, so if the charge is very, very slow, how come there's a current na kaya mag-power up ng mga appliances natin? Okay, kasi diba current is will be Q over T. if the current is very slow in passing through or flowing through the cross section of the wire, why would there be enough current to power up machineries or our devices? Remember that di ba? 1 coulomb is a lot of charges. Although mabagal sila, you are sure that they are moving forward, di ba? In a way, or in general. Now, if there are a lot of them doing so, well, it won't make sense. It won't matter kung mabagal siya o mabilis. Saka ang definition ng current is the number of charges crossing or flowing through a point in the circuit over time. Imagine if there's a race, and then let's say there are turtles kasi mabagal. Just for analogy, million and million of turtles. Okay, and then a lot more. Although mabagal silang gumalaw, take a look at how many will be able to pass through a point in the race or in the racetrack. But that's a lot of turtles passing through. So you can still have large amperes of current. And then another question that you might ask is, kung mabagal yung drift speed, bakit kapag switch on ko yung switch, pinindot ko yung switch, bakit agad-agad na nagliliwanag yung ilaw sa itaas? There's no time delay. Di ba dapat aantayin? Medyo mag-antay muna ako ng konti because the charges will be slow in moving. Your problem if you have this type of question is, you think that, for example, you think that the charges are coming from the battery. Is that the case? Are the charges coming from the battery? Are the charges that will do work on the filament of the bulb be coming from the battery? Hihintayin pa ng light bulb yung mga charges from the battery to do the work. So actually not, diba? Remember, you have a conductor. That means this wire, and then the wiring in the light bulb, and then the filament itself, all of these are conductive materials. So they have a lot of mobile electrons themselves, or mobile charges themselves. Okay? So the charges that are actually immediately doing work on the filament ay yung mga charges that are around it or beside it, near it. Okay, it's not waiting to be supplied by the battery. Let's think about the water circuit analogy. Bakit kapag nabukas ka ng gripo, there's already water coming out? Because meron na, di ba, yung pipes mo, puno na siya ng tubig. And then, when you open the faucet or the spigot, the water that's coming out are the water near the faucet, near the opening. Okay? So, you're not waiting for the water dun sa tank to go out of the faucet. Okay, wow, that's the end of it. So summary, an electric current is defined mathematically as Q over T, that's the amount of charge flowing through a point in the circuit over time. Okay, this is it. The unit of current is ampere, A, or amps. Ang pangit pala nung amp. Its value is the same throughout the circuit. So you can take any point in the wire and then the current will be the same. Kahit pa you're talking about this wire just after the light bulb or just before the light, all of them, all throughout, the current is the same. There's a convention in the way we see the charges flow throughout the circuit. It's called the conventional direction. It is as if it is the positive charges that are flowing from the positive terminal towards the negative terminal. And then charges will actually collide with the atoms of the wire, making the individual movement slow. And then the charges that immediately do work on the electric loads, or in our case, the light bulb, are the charges of the wire and the load itself. Okay, it's not being supplied by the battery. The only purpose of the battery is to provide the quote-unquote reason for the charge to flow, to provide the potential difference, okay, and to maintain that potential difference across the terminals.